Hello and welcome back to Advent of Code. We're on to the year 2018. We're going forward in time since 2017, which was, of course, a few months ago. Um, where's the website? Yeah, so I have a new computer with a new keyboard, so finally I'm able to press certain buttons that I couldn't before, like Shift and Caps Lock and F1 and F2. And one or two other buttons. Whole new programming experience. All right, so these are the years that I've done before. 2015, 16, 17, and 2020 and 22 I did live. So I'm sort of trying to catch up before next December, which is coming up. So I've got to finish these 3 months before then. All right. Last time in the last series, I was using ChatGPT as a comparison to seeing if I could beat ChatGPT, and the majority of times ChatGPT beat me. All right, I'm going to stop doing that now because I think we get the point. ChatGPT is a better programmer, except in some really tricky cases where I actually outperformed ChatGPT. But we get the message now. AI is really smart. I'm not going to bother with that anymore. I'm just going to code them myself. So let's begin. One more thing. Why is there black space at the bottom there? This is not sized correctly. There we go. No, there's still a... Why is there a little black space at the bottom here? This is full resolution window. No, it doesn't matter. Let's put some music on. Okay. Day 1. 2018. Day 1. Yay, lots of reading. All right. We've detected some temporal anomalies. One of Santa's elves at the Temporal Anomaly Research and Detection Instrument Station tells you. She sounded pretty worried when she called you down here. At 500-year intervals into the past, someone has been changing Santa's history. Oh, so last year we had kind of like a Tron-like thing where we went inside the computer and did stuff. Now, what is it, a time travel thing? Love a good time travel story. Chronal calibration. Okay. The good news is that the changes won't propagate to our time stream for another 25 days, and we have a device. She attaches something to your wrist that will let you fix the changes with no such propagation delay. It's configured to send you 500 years further into the past every few days. That was the best we could do on such short notice. The bad news is that we are detecting roughly 50 anomalies throughout time. The device will indicate fixed anomalies with stars. The other bad news is that we only have one device, and you're the best person for the job. Good luck! She taps a button on the device, and you suddenly feel like you're falling. To save Christmas, you need to get all 50 stars by December 25th. That's usually the drill. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck! After feeling like you've been falling for a few minutes, you look at the device's tiny screen. Error. Device must be calibrated before first use. Frequency drift detected. Cannot maintain destination lock. Below the message, the device shows a sequence of changes in frequency, your puzzle input. A value like +6 means the current frequency increases by 6. A value like minus 3 means the current frequency decreases by 3. Starting with 0, what is the resulting frequency after all of the changes in frequency have been applied? Oh, well that's easy. Nice, easy warm-up. Alright. So, let's do this then. Is that a good size? Seems okay on stream. I could zoom in a bit more. Oh, I think it's fine. Alright, so we want our input. Alright. So, we want total equals 0 while, sorry, with input dot, how do you, oh no, you do open input dot text read only. I just do that for safety. SF for line in f dot read lines. So for each line, just want to cast it to an int. Python knows how to do that. Just print the total. That's it. Run. 445. Correct. Part 2. You notice that the device repeats the same frequency change list over and over. To calibrate the device, you need to find the first frequency it reaches twice. What is the first frequency your device reaches twice? Okay, I don't need to read the example, that's clear enough. So this time we use a hash set or something. Say, this is part 1. Scene equals set. Now do this. If int line not in, oh, is in scene, print int line. So this is kind of part 2, except it will print more than we need, but we're smart enough. Oh, and also scene.add int line. Keep track of what we've seen before. This is not the best way to do it. Let's say I don't know. Part 2 done equals false. There we go. Minus 10? But we're talking... Oh, no. No, we're talking about the frequency our device reaches. So we do if total, print total, That's it. First frequency reached twice. Oh! I get it now. Alright, so actually this is all slightly wrong. Okay. Take this out. Okay, start afresh part 2. That's a better way to do it. Alright. Total equals 0. Scene equals set. Okay, we want to do this over and over again while true. Do all of this. So we repeat the whole list of frequencies until we actually hit a duplicate. So we go full line. Alright, if total in scene we want to break out of here. Okay, so as soon as we've seen a duplicate total, we break out fully out of both loops. So just keep going until... Okay, there we go. 219. Keep going until it sees a duplicate. Should be all we need. Correctamundo. There we go. We have our first pair of stars. On to day 2 already. That was a nice easy warm-up. Inventory management system. Oh yeah, love inventory management systems. That's a big chunk of reading. You stop falling through time, catch your breath, and check the screen on the device. Destination reached. Current year 1518. Current location North Pole Utility Closet 83 and 10. You made it! Now to find those anomalies. Outside the utility closet you hear footsteps and a voice. I'm not sure either, but now that so many people have chimneys, maybe he could sneak in that way? Another voice responds, actually we've been working on a new kind of suit that would let him fit through tight spaces like that. But I heard that a few days ago they lost the prototype fabric, the design plans, everything. Nobody on the team can ever seem to remember important details of the project. Wouldn't they have had enough fabric to fill several boxes in the warehouse? They'd be stored together, so the box IDs should be similar. Too bad it would take forever to search the warehouse for 2 similar box IDs. They walk too far away to hear anymore. Late at night you sneak to the warehouse. Who knows what kinds of paradoxes you could cause if you were discovered. And use your fancy wrist device to quickly scan every box and produce a list of the likely candidates. To make sure you didn't miss any, you scan the likely candidate boxes again, counting the number that have an ID containing exactly 2 of any letter, and then separately counting those with exactly 3 of any letter. You can multiply those 2 counts together to get a rudimentary checksum and compare it to what your device predicts. Okay. Seems alright. So... Okay, so we're gonna reuse this code snippet. Alright, so... What do we do? So we need a method for checking if a string has exactly n of a letter. Alright, I think we want to use a useful thing here. Counter. So we want to keep two counts here. Num exactly 2 of a letter. Num exactly 3 of a letter. So num exactly 2, we want to say we want counter of string dot values that gets the counts for the letters. We want to say 2 in 2. There is at least one letter which appears exactly twice in the values of this counter. Counter maps each letter to the number of times it appears in the line. So that will add 1 if there is a 2. And do the same for 3. And then what did they want us to do? Multiply those two numbers together. Is that it? 6474. Correct. Confident that your list of box IDs is complete, you're ready to find the boxes full of prototype fabric. The boxes have IDs which differ by exactly 1 character at the same position in both strings. How many... There's only 2. Okay, that's easier then. So, the IDs ABCDEE and AXCYE are close, but they differ by 2 characters. But FGHIJ and FGUIJ differ by exactly 1 character. So the question is, what letters are common between the 2 correct box IDs? So we're trying to find a pair in this list that are exactly the same except for 1 character. Okay. We can really just brute force this. How big is this list? 250. So we can just do a quadratic find all pairs. Okay. So we do this, but we do this list twice. So for line 1, for line 2. Alright, so we've got line 1, we've got line 2. We want to count how many characters are common between the two. No, we want to count how many differ between the two. What's the easy way of doing this? Just keep a count. Differ equals 0 for high in range and line 1. We should strip the new line characters, I just don't like using them. If so we differ line 1 I is not the same as line 2 I. So for each character where they differ, we add 1. If differ equals 1, exactly 1, we're not actually recording. What were they asking for? What letters are common between the two correct box IDs? Oh. Well, are we allowing duplicates, or are there actually no duplicates? Yeah, because there's 2 V's, for example, so I assume we don't want to list them twice. So we can just use a set then. Just say print set of line 1 dot, make sure we strip, intersect. How do you intersect the sets again? Oh, I've got to look this up. Python set rotation. Is it the circumflex or whatever it's called? Union. Ah, it's ampersand. Makes sense. Set. Oh. No, this is wrong. Because it's going to be in order. It's ordered. And we also, I guess we don't actually want to remove duplicates. You know what? I can't be bothered. Just print line 1. I'll do it by hand. Break. It's only going to happen once, so... Oh, wait, are we allowed to do this? If you call f.readlines again, what happens? Alright, let's just do this. I think it's the same handle, so it's yeah, you don't want to do this. Okay, so strings, just for line in f.readlines, strings.append line.strip. Okay, do that. Okay, now for let's call it S1 in strings. Or S2 in strings. It doesn't matter if we pull up the same string, because that won't differ in exactly one place anyway. So and here we go, S1, 2. So do that. Huh? Hang on. Exactly one character. What have we got here? MX, Woggle, Lux, GUI. So they differ by D and I. Oh, because it's doing them both. Ah, damn it. Okay, fine. So it's done it twice because it found it twice. That's fine. That could be fixed, but I can't be bothered. So we just take that string, but we take out the I. Like, and that's what's left. So we just give that remaining string, right? Correct. We're on 3. No matter how you slice it. The elves managed to locate the chimney squeeze prototype fabric for Santa's suit, thanks to someone who helpfully wrote its box IDs on the wall of the warehouse in the middle of the night. Unfortunately, anomalies are still affecting them, so we're going through time and we're kind of fixing everyone's problems. Nobody can even agree on how to cut the fabric. The whole piece of fabric they're working on is a very large square, at least 1,000 inches on each side. Each elf has made a claim about which area of fabric would be ideal for Santa's suit. All claims have an ID and consist of a single rectangle with edges parallel to the edges of the fabric. Each claim's rectangle is defined as follows. The number of edges between the left edge of the fabric and the left edge of the rectangle. So it's basically the X value and the Y value. Okay. The width and the height. Reasonable. Okay. So for example, hash 123. So that's its ID. 3 from the left. So 0, 1, 2, 3. Cool. 2 down. And then 5 by 4 is its width. Okay, that's fine. The problem is that many of the claims overlap, causing 2 or more claims to cover parts of the same areas. Yeah. The 4 square inches marked with X are claimed by both 1 and 2. If the elves all proceed with their own plans, none of them will have enough fabric. How many square inches of fabric are within 2 or more claims. So this is kind of probably a hash set problem. So we've got 1000 by 1000, so there's 1,000,000 spaces. The rectangles could be as big as... Ooh. Ah, but they're quite small rectangles. So if the rectangles were like about 1000 by 1000, then doing that 1000 times would be too much. But because it's like 10 by 10 or 20 by 20 or so on, then it's kind of like probably doing about 1,000,000 operations overall, which is fine. Yep, that's good. We can brute force this then. Just count how many coordinate pairs are used twice, really. Okay. Download grammar and spelling checker for Asturian. No, thank you. That looks like Asturian? What the heck is Asturian? Is that... It's the historical language of Asturias, portions of the Spanish provinces of León and Zamora, and the area surrounding Miranda do Douro in northeastern Portugal. How can I see an example of Asturian? Puerta. It looks like Spanish. So how on earth did the IDE think this was Asturian? What the f... Alright, whatever, just continue. Okay. That was weird. Alright, so, so we basically got to unpack these. So we want... so we want to keep track of the coordinates we've seen. So let's say covered is how many spaces are covered by fabric. So it's a set. But we also want to have a set called double covered, which is the ones that cover by at least 2. Alright. So we do... So we take a line and it looks like this. Dear. Right, so... I normally don't bother with regex. I normally just tokenize things. Maybe this is a good chance to use regex. I'm not very fast with it, but it'll be good practice. Let's try. So let's just write down what this looks like. Remember that the hash symbol is actually like that. Okay, so... port regex. So we want pattern equals... How do we do this? Alright. Let's use the old regex checker. Builder, whatever. So that's what we want to catch. So it's sort of like that, but we want... so the number will be D plus then we got another D plus here. And then another one here. And then one more here. And one here. Make sure that works for a few cases. So it's hash number. There's a space there. Oh yeah, because of the... Yeah, there we go. Okay, that matches. That's our pattern then. Okay. So we want GM. What? I chose the... Just fiddling around with the options here, it seems like... Let's test this out then. So we've got that. I don't remember what code you use. So you say matches equals, alright, something like this. RE dot match. But we don't want one match, we want... No, that's not quite... RE dot... What does that do exactly? Alright, let's print match. Is that just a tuple? Dot group? Is that what we want? No. Dot... How do we unpack it now? Oh, I have to look this up. Oh, groups. Hang on. Match dot groups. What does that give us? No? Alright, let's just have a look at the documentation. Oh, so we have to parenthesize the things we want to actually capture. So we want to do that. Let's test this. So group 0 should now give us the integer there. Yes. Okay, I mean, it would have been faster for me to just tokenize everything, but I've got to get some practice in with regex. It's useful, and it's safer. Once you actually do it correctly, it's actually safer than all that tokenization stuff. Groups. Okay. So now what do we need? The ID num we don't actually care about. We just care about the okay, so X, Y. So don't care about the ID num. We care about the X, the Y, the width and the height equals int z for z in match dot groups. What's the 0 in the group mean? I don't know. I think this will work though. So just test print xy. There we go. Okay. Alright, we're getting somewhere. Now. We need to range over all elements of this rectangle. So we've defined a rectangle with these coordinates and the width and the height. So I want to do for I, let's say I in range. So we do x plus, so it's going to be x starting at x and finishing at x plus w minus 1 for j in range y plus h. Now we've got a coordinate pair. If I, j is already in covered, then that means it's now double covered. Alright. And we make sure it's covered. now that we've checked. So after all that, print length double covered. We're trying to... Okay, let's try that then. 124850. That sounds about the right kind of amount that we'd expect with all these rectangles. Correct? Alright, amidst the chaos, you notice that exactly one claim doesn't overlap by even a single square inch of fabric with any other claim. If you can somehow draw attention to it, maybe the elves will be able to make Santa's suit after all. For example, in the claims above, only claim 3 is intact after all claims are made. What is the ID of the only claim that doesn't overlap? I think, okay, there's a couple of different ways we can do this. I think now that we've built up this double covered map, we can now go back through all the claims and check whether for each claim, every single pixel in its rectangle is not double covered. That means it's not overlapping with anyone. So we've already built the kind of the data structure we need. We just need that noise. So now we have to go back through this whole list. So we go through all the claims again. So, okay, so we say is overlapping equals false. Right, now we range through all its contents. Blah, 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 blah. If ij in double covered, that means it's overlapping, so we want to break out of the whole thing. Okay, just break out of that, that's fine. We'll go through that. If is overlapping, print. Okay, we need to capture the ID num. And just break out of this loop as well. Why is that a typo? Why do I have spell check on? Why? Ugh. Let's turn up spell check. This is nonsense. I know how to spell. Spelling. Turn it off. Okay, first of all, Great Britain is the only English for me. Second of all, Britney Spears must be what? They have a special rule just for Britney Spears? Okay, I don't care about all this. Turn off spelling altogether. It should be here, right? I don't care about custom dictionaries, I just want to turn off spell check. The text. Okay, turn that off. No, what the heck? Spell. Disable Grazi Light. I don't know what that is, but I think that's the plugin that's doing this. Okay. No, don't restart. We have to restart for that to take action. Okay, so if I run this now, will it just... 1? That can't be right. Oh no, I've done this the wrong way around. Hang on. If it's in double covered, then it's overlapping. We want to say if it's not overlapping, then we proceed to print the ID num. There we go. Because all the others are overlapping. 1097. Correct. Alright, we're on to day 4. Repose record. You've sneaked into another supply closet. This time, it's across from the prototype suit manufacturing lab. You need to sneak inside and fix the issues with the suit, but there's a guard stationed outside the lab, so this is as close as you can safely get. As you search the closet for anything that might help, you discover that you're not the first person to want to sneak in. Covering the walls, someone has spent an hour starting every midnight for the past few months secretly observing this guard post. They've been writing down the ID of the one guard on duty that night. The elves seem to have decided that one guard was enough for the overnight shift, as well as when they fall asleep or wake up while at their post. For example, consider the following records, which have already been organized into chronological order. Guard 10 begins shift, falls asleep, wakes up, falls asleep, wakes up. Fine. Timestamps are written using year, month, day, hour, minute format. Okay. Guard falling asleep or waking up is always the one whose shift most recently started. Because all... Alright, fine. Sometimes he starts before midnight, sometimes after midnight. But you... So you need to basically look at one chunk before the next begins shift section. Visually, this record will show that the gods are asleep at these times. Okay. Wait, so God 10 and God 99, God 10. Okay. God 99 begins this shift on the same day as God 10 finishes, so that's a bit weird. Okay. Columns are dates, which... Guards count as asleep on the minute they fall asleep, and they count as awake on the minute they wake up. Okay. Fine. Hello, Ku. Yay, every programmer's favorite, dealing with timestamps. Although it seems like we don't actually need to dig in too much with the actual meaning of the timestamp. Seems mostly just counting individual minutes that he's asleep. Alright, here's what we want to do. If you can figure out the god most likely to be asleep at a specific time, time as in... Oh, okay, so we're gonna choose a specific minute of the hour and work out which god is most likely to be asleep at that minute. That's good, because that just gets rid of all the date and hour stuff. We don't care about anything other than the minute, and we just count all... Well... What annoys me is this example here. This guy began his shift before midnight. But I assume we can pretend he began his shift at midnight because they don't care about the minutes before midnight. So could I just replace all those with 0000? Yeah, that would make sense. Then I don't have to deal with... Well, I'll have a look at the data and see what we've got. Strategy 1. Find the guard that has the most minutes asleep. What minute does that guard spend asleep the most? Oh, okay. Well, that's actually simpler then whatever. I guess strategy 2 will be the one which is more accurate. Find the guard that has the most minutes of sleep. The total count of minutes of sleep across all days that he's operated. So whenever they begin a shift, they begin awake. So we only care about the falls asleep and the wakes up. Is there always a corresponding wakes up before the next shift begins? It seems like it's always falls asleep and then wakes up, and then it's not like falls asleep and then someone else begins the shift. So there's always a wakes up to close the falls asleep. That makes it easier. Okay. Alright. Let's have a look at this input then. So yeah, there's some 23s, but there's never... Do they ever go earlier than 23? So we can say if the hour is 23, then we can just replace the minute with 0. Pretend they began the shift at midnight. What is going on here? 4:09 begins shift. Falls asleep. Wakes up. Wakes up. Wakes up. Wakes up. Wakes... Oh, have I misunderstood how this actually... Oh, it's not... The order is not chronological. It's... How does this work again? But we can order it chronologically if we want to. We might as well, because this doesn't make sense otherwise. Otherwise we have to keep track of who, when, what. So if we start by sorting the data chronologically, then it makes sense. Okay. Now, this is not hard, but it's a bit confusing to unpack. Right, so we want with open, all right, let's say all right, let's do a bit of parsing here. Let's say, I could use regex. I don't care about... Oh, I do care about the date. Alright, let's just first sort out the data. So let's say... This is fixed width, so we want so timestamp equals, let's say, line from, where's the line numbers? But row column numbers. Okay, we'll go from 1. Ignore the square brackets. 1 to 17. Yeah. Let's say action equals from 19 onwards. Okay. So let's say the log equals this list that we're going to put everything in. Log.append timestamp action. Log.sort. Alright. Or L in log print L. Let's see what we're dealing with here. So does this actually make sense now? This is completely chronological. So every falling asleep will have its corresponding wakes up. Okay. So we want to find the god that has the most minutes asleep. And what minute does that god spend asleep the most? So basically, for each god, we want to keep a counter which maps each minute in the range 0 to 59 to the raw count of how many times the god has been asleep in that minute. It looks like... Oh. It looks like the fact that they begin shifts before midnight is not actually an issue, because he wakes up, the falls asleep is it always after midnight? I think they said something like that. Let me check the description again. So we don't, it doesn't matter then. Because all asleep awake times are during the midnight hour. Okay, fine. Good. We don't care about the 23. Okay. So what now? So we want to... want to use a counter. All right, for ln log, so we need to keep track of a current guard is asleep. Those are basically two things we need to keep track of for each individual log. So for each ln log, if we see that the action is begins shift, so if L, so the action dot begins, so it's a string, yeah, dot, no, starts with, let's say, guard, then we say so when let's say guard sleep counters equals a hash map which maps the guard ID to their respective sleep counter. So guard ID equals, so it'll be, how do we unpack this? L1 dot split by spaces, take the second item, ignore the hash, and cast that to an int. Or we could take it as a string, it doesn't matter. If we haven't yet encountered this guard, then make a fresh counter. Okay. So then we say current guard is this guard ID. Is asleep is false, because he's awake when he begins his shift. Okay, so this basically resets. Every time guard begins shift, we change the guard ID and the is asleep parameter. Okay. We don't even need an is asleep parameter. All we need is last... What am I trying to say? The last time he went to sleep, or when he went to... The time he went to... The sleep... time... The sleep minute. This doesn't... Okay, I know what it means, but the minute that he went to sleep, basically. The sleep minute equals none to begin with. The last minute in which he went to sleep, if he is currently asleep. Alright, so okay, no. Sleep minute is none. If he's awake, then sleep minute is none because he's not asleep. Alright. So is this correct for what I've done so far? Yes. Okay. So now elif L1 dot starts with falls asleep. So if we're falling asleep, then we're saying, so the current guard is already fixed. We're saying the sleep minute. We need to unpack the sleep minute. How do we do that? Just say, just find the colon and yeah, okay. So let's say pos equals L timestamp dot find the colon. So the minute equals 0 pos plus 1 onwards. Let's say just int that. Probably should have used regex, but okay, we've gone this far. All right, a minute is that. Okay, so we're saying he's now asleep. So the sleep minute is set to, okay, we can just do this. And that's it. We don't update the sleep counter. We only do it when they wake up. Otherwise, if they wake up, so the wake minute is that. So now we look at what the sleep minute was, which should always exist because it seems there's always a corresponding wake falls to awakes, and in turn there's always a corresponding guard to a falls on awake. We then say for minute in range, so ranging from the sleep minute, when we know he slept, up to the wake minute, but not including the wake minute. We say guard sleep counters for the current guard now we've got the counter, so on this minute we add 1. That gives that particular minute he slept in that minute 1 more time. It feels flimsy, but I think it's okay. What's wrong with L? Alright, anyway, a minute in range. Minute is an int, so that should be okay. Doesn't have to be a string, it can be an int. Try running it, see if it crashes. Okay. So after this runs, we have the full database of sleeps. Okay, now, what is it we want to find again? We want to find the guard that has the most minutes of sleep. So basically the sum of the values of those counters. And what minute does that guard spend asleep the most? Okay, so make a first pass to find the guard that slept the most. Right, for guard counter in guard sleep counter items. So that's sleepiest guard. So let's say 0. Alright, so for guard, counter, and guard sleep. Okay. So the amount that this guard slept is, let's say, x equals count is sum of counter dot values, right? If x is greater than sleep time, then we want to update sleepiest guard. Sleep time equals guard x. Alright, let's see what we get so far. Guard 3209 slept 541 minutes in total. Okay, sounds plausible. And then what was the second thing we want? We want to find the minute in which the minute that they slept the most in. Okay. Okay. Okay, we don't need the sleep time here. So that's the guard. Now, print the max of sleepiest guard. So that gives us the counter. We want to find the key, the max key. Where we map, where the max is taken over the E equals how do you do this again? You want to do dot get without the brackets? Is that will that work? get will take the key and return the value, the count, and we're maxing the count. Normally I write a lambda function, but that seems simpler. Okay. Does that give us something? 32. So they're saying minute 32. Okay, sleepiest minute equals that. And finally, print sleepiest guard multiplied by sleepiest minute. Is that what they asked for? Alright, there's quite a few places this could have gone wrong, so let's try it. $1,024? What? Oh! Whoops. Auto-complete. That didn't sound right at all. There we go, 102688. Come on, if this is actually correct. Nice. I mean, definitely the process is correct. I was just worried that I was just doing a lot of untested stuff there. Maybe it was a slightly long way of... Well, no. Okay, using untested code is just being efficient. Yeah. Advent of code, it certainly is. I mean, it was probably the long way of doing it, but at least I now have a database of times, which is probably going to be needed for part 2. So let's see part 2. Actually, it wasn't really the long way of doing it. I think that's really the way of doing it. Yeah. Okay. Of all guards, which guard is most frequently asleep on the same minute? So now what? We just literally want the highest number in the values section of the counters. Wait, what do they mean by that? Guard 99 spent minute 45 asleep more than any other guard or minute. Yeah. So we now have a counter which just gives us exactly this. It's just the highest value we see across any of the counters. So we need to keep track of the minute and the guard. Okay. Right now, 2. Okay, so let's reuse some of these. Okay, this parameter we want to reuse. Sleepiest guard equals none. We want sleepiest minute equals... Wait. We don't need to keep track of sleepiest minute. We can figure that out. Just say sleepiest guard is none, and we want the raw. Just call it sleep count. What it really means is the highest sleep count across all the minutes of the hour for that guard. Or 0. Okay, so basically it's like this. We say for guard and counters, but it's simpler than this. We say let's say x equals the max of counter.values. If x is greater than the last sleep count, then sleepiest guard equals guard. Okay, so that gives us the guard. And now we can kind of work backwards and find the minute. We just say now for k in, so we want sleepiest guard dot keys. So for every key value we've got, if we find our sleep count again, just print that minute. So if is the same as the sleep count we had earlier, then we print the final thing we want is ID multiplied by minute. Okay, so it'll be sleepiest guard multiplied by a value, which is the minute, I mean, the alternative will just do a max function, which is whatever, it's equivalent. Break. Okay. Max. Where am I using max? Max counter dot values. Oh, if a guard never sleeps, then okay. If not counter.values, there we can just skip this guard. The guard that never sleeps. No, that was for the last one. 688. We don't have any result here. Hang on. No. Wait, why? X. Are we getting anything here? What's going on here? Yeah, we're getting numbers here, so there should be at least one guard. So we should get a sleepiest guard. Oh, I didn't update the sleep count. Damn it. No, don't debug. No, what? Wait, no. Just run normally. 56901. So guard multiplied by the minute. Strategy 2. I think strategy 2 makes more sense. Both strategies aren't really that good though, because it's a raw count. So guards that are on duty more there's a bias towards them, even if they don't actually sleep much. What it should be is a proportion of the amount of time they put into the job, or some sort of scaling. But anyway, 56,901. God, what happened? My internet crash or something? Am I still alive? I'm still alive. There we go. Yeah, no, it's just site timed out or something. All right. Do I have time for one more? Probably not. Need to get to the gym. So that was 4 questions. Oh, okay. Am I still in Phuket? Phuket? When was I last in Phuket? Wasn't that years ago? Did I ever even stream from Phuket? I rarely ever go to Phuket. I kind of don't like Phuket. It's way too expensive and touristy, and do you mean Koh Samui or Koh Phangan? I usually go to the other islands, but never Phuket, because Phuket is just like overrun with the taxi mafia. Like, you literally can't get anywhere without paying higher taxi prices than in London even. No, I'm in Vietnam right now. A lot like Thailand, but like half the cost for everything, both accommodation and food. And beer is much cheaper in Vietnam as well. But it's sort of quieter, and like shops don't open late at night like they do in Thailand and stuff like that. So. When did I move to Vietnam? Like last week. I was in Europe for a while, in UK and France and Greece. Missed this whole saga of Europe too. Well, I didn't stream much from Europe because Europe internet sucks. Like several places I stayed at. Greece is the worst. Greece, oh my god, Greece is terrible internet. Like 4 different places I tried, both hotels and Airbnbs, never anywhere with more than like 0.5 megabits per second internet speed. Apparently Greece is just terrible internet infrastructure overall. Like I've seen faster internet in Africa than I have in Greece. So yeah, Greece is a cool place to visit if you want to see the Acropolis and everything, but not if you ever need to use the internet. Going to Cyprus in November. I don't know how Cyprus compares with Greece in terms of internet. It's probably better, I'm not sure. But Cyprus is cool as well. Never been to Africa, but going to Egypt and Tunisia. I haven't been to North Africa for a long time. I went to Egypt a couple of times when I was a kid, but Egypt is... It's like one of the worst countries when it comes to people hassling tourists. You may be aware of that, so you just gotta really stay away from anyone who preys on tourists because they hassle you like crazy. I've had friends who went there and they came from their holidays and they said they hated their experience because of that. But I mean, you can make it work if you just figure out how to avoid them. And like, just don't entertain them at all. Just don't even answer them. Don't look them in the eyes or anything. Yeah, I mean, if it's a private tour, then whoever's organizing your tour probably hates them just as much as you do, and probably will tell them to piss off as long as they, as you know, as soon as they see them. How do I bring up my... Let's have a look at some stats here. Tunisia. I don't think I've ever been to Tunisia. That's where the original Star Wars films were filmed, wasn't it? You can go to the actual Tatooine site. It's out in the desert though, so you'd have to probably hire some private car to take you there, because I don't think there's any like bus which goes there or anything like that. Yeah, and when you're in Cyprus, I guess you can also cross over to the Turkey part of Cyprus, which is cool because it really is like going to a completely different country. It's like suddenly it's all Turkish style. I think you even need to, yeah, 'cause you do actually need to cross immigration to get into the Turkey part as well. What am I trying to find here? Oh yeah, private leaderboard, and the other thing I wanted to see was the stats for that year. Okay, this is what I'm looking for. 1, 2, 3, 4. So for 4, which was the guard one, what were the stats for that? Yeah. Forget how to navigate this site. Leaderboard? Ah, leaderboard 4. 6 minutes for both stars. Hello, Amaro. It was just finishing actually, but I was having a look at the stats. And these were the years before ChatGPT, so it's kind of realistic like times. Nowadays all the leaderboards will probably be dominated by ChatGPT solutions, as they already were the last year, maybe probably not the year before that, but last year, yeah. Six minutes is pretty good for that. But I suppose it's conceptually not that difficult. You're just building lists of counters or whatever. All right. Okay then. I'm gonna get to the gym. Because I didn't go at the weekend because it was closed, because it was like Vietnamese Independence Day or something, which I didn't really partake in. So yeah, I'll carry on with 2018 as a sort of daytime activity. I'll probably be back on in the evening with my evening with GTA Vice City, because I think I'm in the final part of that game, so I'll probably actually finish that off. We'll see. I think I'm on the final mission, but there's like, I think you have to have a lot of, I think the final mission, you can't do it until you have a certain amount of wealth or property or something, so I might need to get money or something. We'll see. All right. Well, see you next time, Ku, and tomorrow.